Welcome to this tutorial on calculating inner products using NumPy's inner function. The inner product is a fundamental operation in linear algebra that you'll use frequently in data science and machine learning applications. The inner product is a mathematical operation that takes two vectors and returns a single scalar value. It works by multiplying corresponding elements from each vector and then adding all those products together. The mathematical notation shows this as the sum of a 1b1 plus a 2b2 and so on through all elements. The syntax for NumPy's inner function is straightforward. You call np.inner and pass two arrays as parameters, and the function returns their inner product as the result. Let's see a practical example with one-dimensional arrays. We create array A containing 1, 2, 3, and array B containing 4, 5, 6. When we calculate the inner product using np.inner, we get 32 as the result. Here's how the calculation works step by step. We multiply 1 times 4 to get 4, 2 times 5 to get 10, and 3 times 6 to get 18. Then we add these products together. 4 plus 10 plus 18 equals 32. The inner function also works with two-dimensional arrays. Here we have matrix A with rows 1, 2, and 3, 4, and matrix B with rows 5, 6, and 7, 8. The result is a 2 by 2 matrix containing the values 17, 23, 39, and 53. For two-dimensional arrays, the function computes the inner product between each pair of rows. Row 1 of A with row 1 of B gives 17. Row 1 of A with row 2 of B gives 23. Row 2 of A with row 1 of B gives 39. And row 2 of A with row 2 of B gives 53. Let's recap the key points. The inner function works with both one-dimensional and two-dimensional arrays. It performs element-wise multiplication followed by summation. For two-dimensional arrays, it computes the inner product over the last axis. The function returns a scalar for one-dimensional inputs and an array for higher-dimensional inputs.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.